Hi everyone, my name is Davor and I'm a Master of Education student at UBC. Today I'll be doing the Graaff Generator demonstration. This should ideally come after you've watched the electrostatics demonstration. Before I start the demonstration, I'd like to speak a little bit about the setup, especially on the day when there's a lot of kids running around. You want to isolate the Graaff generator somewhere in the corner of the room. You want it away from electrical equipment like computers and laptops, and you yourself should not have any electrical equipment on you like a mobile phone. We also don't want kids running around and touching the generator or getting close to it, as they can get shocked. Make sure between every demonstration to ground the generator using the rod. In order to do this, it needs to be connected to the power to be able to ground, because that's how it goes into the ground. Before you switch it into the power though, make sure that it's in the zero position, so in the off position. And warn any parents that might have pacemakers not to get close to the generator. Not even touching the generator, but getting close, even this distance, is close enough for them to get shocked, as I found out myself. We also have a crate set up here, which will be used as part of the demonstration. We use a yellow crate, as we found that that's the best type of color for an insulator, at least for crates. If you don't have a crate, you can also use a rubber mat or a plastic chair. All right, so let's begin the demonstration. Have you ever wondered why when you get out of a car sometimes you get a shock? Or how does lightning work? Well, today we'll be using this generator, it's called the Graaff Generator, to find out how these things happen. Now, you may have gone and checked out the electrostatics demonstration, and you saw that when we rub certain materials together, we can transfer electrons from one material to the other. These electrons are negative, and when they go to one material, they make it negatively charged. And the material that loses the electrons becomes positively charged. Well, in the Graaff generator, this same thing is happening, but just on a much larger level. So you can see there's a belt here that runs up and down the generator. At the top is a roller, and as the belt rubs against the roller, electrons are transferred from one to the other. Now, there's different types of Graaff generators. In some of them, the electrons go from the dome into the belt, and the dome becomes positively charged. In others, the belt releases electrons into the dome, and the dome becomes negatively charged. It all depends on what kind of materials we're using. And if you'd like to learn more about this, you should go to the electrostatics demonstration to see what kind of materials give electrons and what others take electrons. Now, I'm going to turn on the generator. First of all, I'm making sure that I'm away from the generator, and I make sure that everyone else is too. Before I turn it on, I make sure that the knob is set on the lowest voltage level, and I'm going to turn it on the variable mode, which is the number 2 over here. As I turn it on, I should hear a humming. But I don't. Oh, there we go. You'll hear a humming, and as you increase the voltage, you should see the belt start to move. Now let's see what happens after it runs for a while. Make sure that everybody steps away from the generator at this point. Wow, can you see what's happening? The ribbons are lifting up above the generator. Let's see what happens when I bring this rod close. Wow, can you see the lightning? Alright, I'm going to switch off the generator now. So why do you think these ribbons are standing up like that? Well, remember I said we've charged the top of the dome. So whatever charge the dome is, let's say it's negatively charged,
the ribbons will have the same charge. And we know that like charges repel, so that the ribbons are repelled from the dome and they stand up. What do you think will happen if I bring this close to there? All right? The generator's off. This is a grounding rod. Electrons will go from the generator down through the grounding rod into the ground. Huh! Look at that. Again, it was like small lightning, right? And the ribbons went down. Because the electrons left, the dome was neutral, and all the didn't have any more negative or positive charges. They were equal, and therefore the ribbons fell down. This is actually how actual lightning works. In the cloud, we have all these small little water molecules, and they're all rubbing up against each other, and they build up charge in the cloud. And the charge between the cloud and the ground builds up enough so that lightning strikes. And that's what we saw with this.